In this demo, we are going to show a complete 61850 engineering project using a template-based top-down approach with Helinks STS. What you see is the Helinks STS dashboard. On the upper part, you can make the specification. With the import button, you can import any kind of STL file. The system diagram allows you to add the relays to the system. And once the engineering is done, you can inspect the results with the communication editor, then export SSD and SCD files, finally also create human-readable documentation. At the beginning, I'm going to show the starting point. And the first thing I want to show is the system diagram. Here in the system diagram, you see already a bunch of IEDs from different vendors I've instantiated because I wanted to avoid in this demo to instantiate all the IEDs and creating the network connections and so on. All these IEDs are not configured. It's the pure ICD files without dataset, and if there are control blocks, there are predefined control blocks, but the relay configuration has nothing to do with the application that we are going to do. You can see we have two clients, MMS clients, an HMI and a gateway. We have a station bus, we have a process bus, and we have 6 different bays. 4 are feeder bays, 2 are transformer bays. We see that we have process interface units, which are only connected to the process bus. We have bay controllers, bay protection units, and backup protections. These 3 IEDs are connected to the process bus and to the station bus. The applications that we are going to do with these IEDs, naturally we are going to control the switches from the BCU via goose messages between the BCU and the PU. We are providing measurement values by sampled values for the BCU so that we can create RMS information for the gateway and the SCADA. We have trips over the process bus from the protection units, and naturally we also have the sampled values between the process interface and the protection relays in order to make the protection happen. And finally we are implementing a breaker failure scheme, which is where the breaker failure function sits in the BCU, and we will, in case of a failure, first try to open with the goose messages the local circuit breaker, and if this doesn't work, we will send goose messages to the surrounding base to open the surrounding base. Then finally, naturally, we also will have MMS reporting from each of the station bus connected IEDs to the clients. You see in this picture, nearly all the IEDs are implemented. Here in the bay number 2, in the bay number 3, we are missing the bay protection unit. So during the demonstration, we will also then show how to add a new relay to the system. I would like to show you the state of the IEDs. So I'm opening here the communication editor and I just click on datasets, and you see there is nothing. We don't have any datasets in the system. Nothing is configured. But what we have is we have activated, in terms of application profiles, the applications that we want to have in the system. So we have the sampled values, we have the switch control, the breaker failure for the line base, the trip for all the protection functions, and the breaker failure for the transformer base. If you look right now in this applications, there's nothing, because if we don't have a bay, we cannot have any applications implemented. So this is empty right now. And then finally we go here to the closing here the system diagram, the applications, and we go to the single line, and here you see our starting point for the specification. We have a substation which is called Berlin, a voltage level E, 110 kV. We have a bus bar and 2 transformers, And if I'm opening the specification level on station, or the specification on station level, then we see already prepared network control center communication function, so a client logical node for the network control center and the client logical node for the SCADA. So this is our starting point, and now we are going to make a project. On the right side we have bay templates, and we have a template for a line feeder and a template for a transformer. Now I'm taking the line feed template and instantiate it. Make sure that the voltage level E is active, so then this bay is a child of the voltage level E. I give this a name, that's my bay number 1. And so what happens now, you see we have here now a single line that we see. But there's a little bit more than this single line. I can open now the functional specification diagram of this bay number 1. And you see that we have quite a lot of elements. The gray boxes are the placeholders for the relays, so with the bay controller, and the bay controller is intended to implement the control function for the disconnector and the circuit breaker. Here we have the breaker failure function, here we have the measurement function with the MMXUs, and proxies for the sampled values, current and voltages. So when we implement the sampled values, these proxy logical nodes are intended to receive the samples for the BCU, or for this function. We have the bay protection unit, which is for the line here, a distance protection with 3 zones, its own PTRC, and there is also the proxy functions for the samples, and the PTRC here will send its operate to the process interface unit over the process bus, and the PTRC, the trip function in the process interface unit, will receive this operate in order to trip the circuit breaker. Then we have the bay protection, the backup protection with the overcurrent function, here the same. We have the proxies for the currents, and we have the PTOC. The PTOC also is sending the operate to the PTRC of the process interface unit, so we have 2 sources of the trip. The trip itself will, in order the functions, the protection functions, they will also init the breaker failure. So there will be goose messages to init the breaker failure, and the breaker failure will first try with a goose message to reopen or to open again an internal operate on the circuit breaker, and if this does not work, it sends an external operate. So that is the application that we have here. The application we don't see here in this picture. This picture gives us just the static information, the single line, the functions, the logical nodes, and also all the data that we are using, so that you can see here in the signal list. We have 61 data points here in this bay number 1. But when we open here our applications tab now, and go for instance to the sample measurements and open this, and then we see that here we have now some sampled value data exchange configured. We have the current samples and the voltage samples for the 3 phases neutral. The current and the voltages are going to the measurement function. The current and the voltages are also going to the distance function, and the currents for the overcurrent function, we have only the currents subscribed. So this has already also been instantiated by using the application, by using the bay template. I'm closing this now. Just another example, breaker control. Here we see the switch position, which is sent back to the bay controller, so that we can monitor the switch position on the SCADA. And the bay controller is issuing an operate open, operate close in order to operate the circuit breaker. Also, this has been instantiated just by putting the bay in. So, and in this way we are going to finish now the complete substation. So I'm adding now a transformer. That is our bay number 2. I'm adding a line feeder, another one. That's our bay number 3. And a bay number 4. Finally, we take a second transformer, bay number 5, and the last line feeder is our bay number 6. We connect all the feeders and incomers with a bus bar, because then only we have a valid SCD or SSD file. And so when we export the SCD file, we don't get an error message. That's it. Just another look at our application schemes. We look at the sampled measurements, and now you see that we quite have a lot of sampled values configured here. So for all the 24 relays we have publishing and subscribing configured out of the library. Interesting is the breaker failure here, because there you see that we have the trip, which is initiating the breaker failure for the line bay. Then the breaker failure for the line bay has an operate internal, and if we follow this line, we see that it is opening the QA0 of the bay number 1. And if you look at the external, then we see, follow this external line, then we see that it splits up and it is opening the bay number 5, so somewhere here, and it is also opening the bay number 2. So here we have the scheme for the breaker failure implemented between different bays. I'm closing this. So right now we have specified the system, we have the data flow, we have all the logical nodes, all the functions, but this specification has nothing to do with the relays that we have in the system. So now we need to assign the relays to the bays. The logical nodes need to be mapped to each logical node of the specification. We need to check that all the signals are available, and once this is done, we can generate the data sets and control blocks to complete the project. Just make an example here. I'm open the bay number 3, and here is one button which says implement virtual IED of specification with IEDs from STT file. Clicking on this, now you see that the bay controller, which used to be virtual, now became the E03 bay controller. Now this is a physical IED, and in the signal list we also can see that all the data that we have specified here now has assigned a 6150 address, an IED name, a logical device instance, and we have also a status information which tells us that the data is implemented as specified. So this works fine for the BCU. It didn't work for the BPU, because you remember in the bay number 3 there was one IED missing. If you look at the backup protection, there everything is implemented as specified, and the process interface unit, which is an ABB merging unit, also everything is implemented as specified. So now let us just fix this issue with the missing relay. I'm going to the system diagram. That is where we bring in the IEDs into our STD file. And here is a drawer, ABB. There I take the line BPU red 615, so it's for the the bay number 3 is a line feeder bay, so that is the right one. I'm adding this here, and I give it a name, call it E03 bay protection unit. And now I need also to connect it to the networks, so I connect it to the station bus, and here I'm using the access point 1, and I connect it to the process bus, and there I'm using the remaining access point. Just make it a little bit nicer here. For now we don't care about the IP addresses, so I suppress them. And now we have all the relays. I go back to our bay number 3, and instead having a single shot for all the relays, I can also just select here my virtual relay, can say implement, and it proposes me already the E03 bay protection unit. That's a new one that we just created. I say OK, and we see everything is properly implemented. So now that the mapping is done, we can finally go and build the datasets, control blocks and everything. In order to do this, I say close others, say save selected, and I'm using this button here which says configure communication. Say proceed, and now the system is analyzing all the connections and is creating the datasets, control blocks. We can have a look. It has done this successfully, and just check one of the IEDs here. Let's say the new one, the E03 bay protection unit. Where do we have it? E03 BPU. Yeah. So there's some saving then. If there is predefined communication, we deal with this. But the interesting thing is here, publishing MMS reports. We analyze everything that has been specified, buffered data. Now you recognize this is the PTRC, the distance protection operate. So this corresponds to our application for the MMS reporting. We have also here unbuffered reporting. These are the sampled value. That's not nice. It should not take the TCTRs, TVTRs. It should take the MMXUs. I'll have to check this. Then we have publishing goose, and you see here we are implementing a publishing for the trip. The operate general is published through this goose control block, and we also have here a subscriber for it, which is the process interface unit, the SAM 600, and so on. So we can go through all of this and can see in detail what the system has configured. We also see here MAC address, all the parameters, and so on. So this gives us a comprehensive view on what the system has done. We say, okay, now let's check the result. I'm going to the communication editor, and now we can have a look at the data sets. You remember the data sets were empty at the beginning. Now I expand them here, and you see here the dataset name, the number of entries in the dataset, the data object which is in the dataset, and then you see also the control block that is reused. We see how many data attributes are part, and yeah, you can see that's quite a huge number of dataset entries that has been created. That's the dataset. We can have a look at the reports. Here we see for the entire system the report control block. Typically here this BUP is an Alstom with predefined control blocks. Here Helinks has used the first unbuffered control block, added a dataset, and it has used the first buffered control block and added a dataset. We also see the clients here. In here for this PCU, there were no predefined datasets. These datasets have been created by Helinks. So if you open now here this report overview, then we see that's quite a lot of report data created. The same for Goose matrix, and you see all the publishing, subscribing, sampled value matrix. There naturally we see the process interface unit which are sending sampled values, and we see the backup and the BCU and probably the protection unit which are subscribing to the sampled values. So this is nice. Now we can export our SCD file and so for now I'm ignoring these error messages. They have certain reason, but that's not important right now. And in the out folder here we can see the result. That's the SCD file, Berlin version 1 revision 0, created just right now, and I can open this with an XML editor. And then if we inspect this file in detail, we will find all the communication configurations that we have specified also now in this SCD file. I just search for inputs, and okay, here we find the 6-100 source ref definitions in the specification. And if we come through this, okay, that's quite a larger, we say whole word only. Here we come to the xrefs. These are the xrefs for the HMI, and here for instance we have the xrefs for the goose, the operate open, operate close. And the xrefs for the breaker failure, for the positions. Okay, there's everything in.